In this video, I'll provide an introduction to Amazon Web Services, or as it's more commonly called, AWS. So let's start out by thinking about traditional physical data centers, right? We've got all of these costs that are included with a traditional physical data center, including physical security, having some sort of alarm system, having some sort of badge system, some sort of physical security, cooling, having large redundant air conditioning units that keep the data center cool, power, including batteries, generators, right, and all the associated engineering and equipment that has to take place, not to mention just good old-fashioned floor space and realty to place all of these physical systems. Right. Then on top of that, we have to buy the physical compute hardware, the actual servers and hosts that are going to run all of our applications. We have to purchase storage systems, which can be really expensive. And oftentimes we have to purchase redundant storage systems and their software licensing costs with those as well for all the features that we want. We've got maintenance contracts on top of that for everything. We've got hardware failure, so we might want some sort of extended warranty on that. And then we've got all of the networking that needs to take place, along with all of the networking hardware, the physical cabling, and again, maintenance contracts and support on all of that networking equipment. So when you add all of this stuff up, it equates to a really significant amount of cost, right? Not to mention the fact that we need to over-provision, right? So here you see a picture of a restaurant. Why is there a picture of a restaurant in an AWS course? Well, because this is a great analogy for over-provisioning. So here we see a restaurant, right? And it's got about seats for maybe 50 people, right? So let's say that I designed this restaurant, I built this restaurant with the knowledge that there's probably going to be 200 people walking through my door every day. Some people are going to come for lunch, some people for dinner, some people for breakfast. Some people will eat dinner at 4 o'clock. Some people will eat dinner at 8 o'clock. So if I have 200 people through the door every day, there's a pretty good chance that I'm never really going to have much more than 50 people at any given time wanting to sit in my restaurant. So therefore, I can oversubscribe, meaning I only need to put 50 seats in even though I'm going to have up to 200 people per day. This is a very efficient way to use my resources. If I built a 200-seat restaurant, that would be irresponsible and inefficient. Now the drawback is, what if I have a big event going on in town? What if there's a theater across the street and they're showing a show tonight? I might have 200 people come to the door. So in that particular case, in that unusual circumstance, I'm going to have latency. People are going to be waiting for a seat. I'm going to have poor performance. My waiters and cooks may not make the meals the way they usually do, or they may cut corners, right? So I have two options. Right? I can build a really big restaurant that's going to sit empty most of the time. Most of the seats will be empty. Or I can build a smaller restaurant and deal with those occasional spikes in demand. I don't have elasticity in a restaurant. I also don't have elasticity in a physical data center. Meaning, if I have a seasonal increase in business, right? Let's say that I sell widgets and every November around Thanksgiving, my widget sales go through the roof, right? So I need more resources to sell those widgets. I need more ESXi hosts in my vSphere data center to give me the horsepower that I need to accommodate that additional demand. And when the day comes that it's December 26th and now nobody's buying my widgets anymore, how do I sunset all of that hardware that I just purchased? Right? Or is the hardware going to just sit there and collect dust? I don't have elasticity. I can't rapidly expand and contract my resources on demand. How does this change when we get into AWS? Well, we don't have to over-provision any physical hardware. We can get plenty of resources anytime we want at a moment's notice. If we need more virtual machines, we'll spin up more instances. And by the way, if you're new to AWS, that's what AWS calls a virtual machine, an instance. So I can spin up more VMs anytime I want, more instances anytime I want. I don't need to do any physical changes in order to get those instances up and running. And if I don't need them anymore, I can just get rid of them. And the cost contracts automatically with your usage. So again, if you're new to AWS, they have something called the on-demand pricing model, which means I can get new resources on demand. I can spin up more instances whenever I want. I can destroy them whenever I want. This is also the most expensive way to purchase resources from AWS. If I know I'm going to be using something for the next 3 years, there are less expensive ways to do it. But kind of the vanilla offering, the main offering of AWS is an on-demand model. So if I reduce my instances, my costs go down. Right? And as we're thinking about this, we start thinking, well, what are we really trying to accomplish here? Are we trying to become great at building data centers, or are we trying to deliver what the business needs in order to work? Right? Like, for example, this is a great picture, right? Somebody fixing their car in what seems to be an extraordinarily dangerous manner. But anyways, if I know, hey, I need to get to work every day, the most efficient way for me to get to work every day is not to be doing what this guy's doing. It's not to know how to fix a car, right? I don't need to know how to fix a car to get to work every day. I just need to know how to drive a car. I don't need to know how to build a data center to satisfy my information systems objectives, right? But I do need to know how to manage a database. I do need to know how to set up a web server. I do need to know all of that stuff. Right? So ideally, what should I be focusing on? Fixing the car, or just having a reliable car that somebody who's a professional has already prepared for me, has already fixed for me, it's ready to go, and I can just drive to work. That's the kind of shift in thinking that we sort of have to embrace as this march towards the cloud continues. Because as system administrators or as network administrators or whatever you happen to be, this is a period of great change, right? It reminds me of, back in the old days, there's a lot of people who rode horses and drove horses and buggies. And eventually cars came, right? You either learned how to drive a car or you became obsolete. Well, that's kind of where we are now, right? We have to learn this new way of doing things or we're going to become obsolete. Right? So that's how we start to align information systems to the business needs, right? We can now have this is an assembly line, right? That revolutionized the way that the auto industry built cars, right? And that's kind of what we're looking to do here. We've already got data centers that are secured, that are physically secured, that have all the air conditioning and power systems and all of that stuff. They're all over the globe. So we have all kinds of redundancy that we can take advantage of. Right? So now let's just start consuming these resources and potentially saving ourselves not only a lot of money, but rapidly increasing our agility and our ability to go global and the speed with which we can turn up new services. So like I said, does this really make the system administrator obsolete? Well, what do you really work on day to day? Are you in the data center every day racking and stacking and cabling? Or are you primarily dealing with applications? Are you primarily dealing with applications like databases, like web servers, like Office and Exchange and all of those other things? If so, then most of your knowledge transfers, and it doesn't necessarily make you obsolete. You still have to understand application requirements. You still have to know what does this need from a CPU or graphics or storage or networking perspective. We still need all of that stuff. Okay, so a few key basic AWS concepts here. Regions and availability zones. So regions are simply exactly what they sound like. A geographic area. There are currently 15 regions that exist, plus a region specifically dedicated to government called GovCloud. Regions are dynamic. There are always new regions either being launched or in the works. Region for Africa is anticipated soon. So the thing you need to know about regions with AWS, and at this moment I'm specifically talking about AWS. So if you are a VMware Cloud on AWS student, understand that I'm specifically just talking about AWS at this point. Across the 15 AWS regions, there are a variety of services that are available. There's DNS services called Route 53, there's S3, there's EC2, and then there's some more little minor specialized services that don't get used as much, or maybe that are just really new. As a region rolls out, it has a basic set of services that it supports, and then over time, these other services that are newer or that are less frequently used kind of spread out. Right? So different regions may have different services available. Right? So just understand that whatever region you're working in may not actually provide all the services, so you may need to launch resources in a different region. And each region is made up of multiple availability zones. Right? So an availability zone is made up of one or more data centers within a region. It can be one data center, it could be 5 data centers, it could be 3 data centers, but it's made up of one or more data center within a region, and there are 2 or more availability zones in each region. These give us the ability to create solutions like, for example, AWS has a service called RDS, a relational database service, where you can create a SQL database. Well, you can create a SQL database on RDS and you can set it up as a multi-AZ RDS instance with one instance of the database running in one availability zone and a standby instance running in another availability zone. This gives us the ability to create fault-tolerant solutions within an AWS region. Now, if you are a VMware Cloud on AWS student, understand that at the moment, VMware Cloud on AWS is only available in the US West region. And that's really important if you're considering going to that solution, because let's say that you have other resources in your AWS account, resources that are native to just AWS. If that's the case, you want to go ahead and put the resources in the US West region that your VMware Cloud on AWS is going to be working with a lot. You want to keep those things in the same region. So just something to kind of bear in mind as you choose a region. Eventually, we're going to have US East and many other regions on VMware Cloud on AWS, but the building process is still happening. It's very new. I'm recording this video October 1st, 2017. It's only been out for about a month.